My students are working out of the Carnegie math program this year, and one of our assignments is having students determine fractional parts of a whole. And we are comparing those fractional parts to other fractional parts of a whole to determine which has the greatest fractional part. Now, here we have a situation where some sixth grade students are designing patches, and the patches have some solid units as well as some polka dot units like we see here. And the students' names are Bill, Sarah, Dale, and Mary. I just made those names up. I don't actually have students with those names, but this is just for demonstration purposes. Now, Sarah, she said that she has the greatest fractional part in polka dots. We need to put the students' patches in order from the smallest fractional part of polka dots to the largest fractional part of polka dots. So what we need to do is determine what fractional part each patch is polka dots. Now, excuse me, when we look at Bill's here, we need to come up with his denominator. And with Bill's denominator, we just simply need to write down the total number of units in his patch. And he has 1, 2, 3, 4. So I'm going to write down 4 as a denominator. Now, the fractional part of Bill's patch, that is polka dots, is going to constitute this one little unit that is polka dots. So I'm going to put a 1 to represent that one unit. So 1/4 of Bill's patch is polka dots. Now with Sarah's, we have to count up how many total units she has for her denominator. And here she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I've had students before who would want to count just those units that are solid. They'd want to count those, and they would think that'd be their denominator. No, you have to count all the possible parts for your denominator. That's what a denominator is, the total possible parts. Now, for the numerator, we just simply count how many units have polka dots, and here we have 1, 2. So I'll put a 2 here. Now, I'm going to reduce that, and the way that we reduce fractions to simplest terms is we divide both the numerator and the denominator by the greatest common factor of the two numbers. In this case, we have a 2 and we have a 12. The greatest common factor of 2 and 12 is 2. So if I divide the numerator by 2, that's going to give me 1, because 2 divided by 2 is 1. And if I divide the denominator 12 by 2, it's going to give me 6. So I can say that 1/6 of Sarah's patch is polka dots. Now let's go to Dale's here. Now, I'm not going to count each individual unit. What I'm going to do is I'm going to count how many vertical units, how many horizontal units. I'm going to multiply that, and that will tell me what his denominator is. So here I have 1, 2, 3, 4, and I have 1, 2, 3, 4, 5. So if I multiply 4 and 5, that's going to give me 20. So the denominator for Dale's fraction is going to be 20. Now, how many units are polka dot? We have 1, 2, 3, 4. So 4/20ths of Dale's patch is polka dot. But I can reduce that down to simplest terms. And the greatest common factor of 4 and 20 is 4. And if I divide 4 by 4, that's going to give me 1. And if I divide 20 by 4, that's going to give me 5. So that's 1/5 of Dale's patch is polka dot. Now let's go to Mary's. Mary has 1, 2, 3, 4. 4 by 1, 2 by 2, that would be 8. That's going to be her denominator. And she has 1, 2 units that are polka dots. So I'm going to say 2/8. Now I want to simplify that down, and once again, the greatest common factor of the numerator and denominator, 2 and 8, is 2. And if I divide 2 by 2, that's going to give me 1. And if I divide 8 by 2, that is going to give me 4. Now, one of the benefits of reducing these down is now I have unit fractions. I have 1/4 for Bill, 1/6 for Sarah, 1/5 for Dale, and 1/4 for Mary. Now when it comes to unit fractions, the larger the denominator, the smaller the value of the fraction. So it's easy to decide if Sarah is correct. Sarah thought that she had the greatest fractional part in polka dots. But when we look at her fractional amount, she has 1/6, and that sixth is the largest denominator of our four fractions. So in reality, she does not have the greatest fractional part in polka dots. So we go back to our original question, and that is, well, not our original question, but our original directions. We need to put the students' patches in order from the smallest fractional part polka dots to the largest fractional part of polka dots. Then we need to say that Sarah has the smallest fraction part with 1/6 part in polka dots. And then we can say our next smallest would be Dale. Dale has the next smallest amount with, forgive my typos please, 1/5 polka dots. And then we can say that Bill and Mary have the same amount of polka dots with 1/4. And we'll leave it at that. Now, our next part of this question is Agnes, our next part of the question is Sarah's claim right that she has a design with the greatest fractional part in polka dots? And then we need to explain our reasoning. Well, if she has 1/6, does she have the greatest amount? No, she only has 1/6, which is less than all the other students in this group. So we can just simply say no. Sarah is not correct. She only has 1/6 in polka dots, which is less than all the other students in the group. Now, we need to complete a table that lists the fractional parts of each pattern for each student. Now, when we fill out our chart, I don't want to use the simplified versions of the fractions. I think that for this part it might be best to use the original fractions. Now let's look at Bill's. We need to know what fractional part of Bill's patch is solid and what fractional part is polka dot. Now we already know the fractional part that's polka dot because we said 1/4 of it was polka dot earlier, so I'll just put 1/4 there. Now I have solid 1, 2, 3. That's going to be my numerator. My denominator still needs to be 4, the total number of possible parts. So 3/4 is solid, where 1/4 is polka dot. Now with Sarah's, we already know that 2/12 of her patch is polka dot, and when it comes to the solid part, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, and our denominator is 12 because there are 12 total fractional parts, 10 total parts. And for Dale's, we already know that 4/20 is polka dot. Now, I don't really have to count all those. I can figure out how many units are solid simply by thinking if 4 out of 20 is polka dot, Well, then that's going to leave 16 that are not, 16 that are solid. So 16 over 20. And with Mary's, I know that she has 2/8 that are polka dot, and I'm just going to do the mental math here. 2/8 is polka dot. If 2 out of 8 are polka dot, then the remaining 6 are not. So 6 over 8. Now, this is pretty much how I would have completed that assignment if I were a 6th grade student and had the benefit of answer keys and that sort of thing. But I hope that it gives you a good idea of how to figure out fractional parts of a whole and how to compare those fractional parts. I also hope that you got a little something out of the reducing to simplest terms lesson. You look for the greatest common factor, both the numerator and the denominator, and you divide both the numerator and denominator by that same greatest common factor, and that will give you your reduced to simplest form fraction. Thank you.